to Sparkling STEM. In this session of our colourful chemistry, we're going to look at a beautiful crystal called potassium permanganate. Now, potassium permanganate, of course, has potassium, manganese and oxygen in this compound, and it's in the form of these tiny little beautiful crystals. Now, if I take this beaker of cold water and I add just a tiniest amount of these crystals, you can see there, to the water, you'll see that as they go in, they dissolve and form this beautiful pinky purple colour. And you'll see that it's sunk down in little threads down to the bottom, and very slowly that colour is spreading out throughout the water in the beaker using the process of diffusion. Now, diffusion is when liquids or gases spread out from an area of high concentration, where there are lots and lots of those particles closely together, to an area of lower concentration, where there are fewer of those particles or none. We can say that they go down the concentration gradient from a high concentration to a low concentration. It doesn't take any energy to do this. They already have all the energy needed, but just because the particles, the molecules, are moving around with some kinetic energy and bumping into each other, which makes them spread out. If I do the same thing in hot water, this is about 70 degrees, the water in this beaker, using a similar amount, ideally to compare I should be using exactly the same amount, but you'll see we've got a very similar amount, just a few little crystals there. In hot water, as I add the crystals, you'll see the same thing happens with the colour. It forms this very deep, dark purple, beautiful manganese colour, and it spreads out throughout the water, turning the whole of the water purple. But because the water is hot, the molecules of water have a lot more kinetic energy. They're moving around a lot more, and so they bump into each other a lot more. And every time they bump into each other, they get spread further and further apart, carrying the potassium permanganate with them. So the potassium permanganate diffuses much more quickly in hot water than it does in cold water, because there's a lot more heat energy, making a lot more kinetic energy for the water molecules and carrying those particles of potassium permanganate around the water much more quickly. And you can see that even though I added the potassium permanganate to the hot beaker, after I added it to the cold beaker, it's already caught up with it and overtaken it, diffusing and spreading out throughout the water. If we leave it long enough, then those particles of potassium permanganate should spread out until they reach equilibrium. That's until everything's in balance and all those particles are evenly distributed throughout the liquid. So there we go. Potassium permanganate showing us the process of diffusion and how particles spread out from where there are lots of them, high concentration, to where there are fewer of them in a low concentration, and how it happens faster when there is heat energy than when there is less heat energy.